Assalamualaikum and a very good morning. My name is Fariha binti Mansur from Polytechnic Sultan Salahuddin Abdul Aziz Shah Alam, Selangor. I would like to present a research paper on National Research and Innovation Conference, Nricon 2020. My paper ID is 2008 3110.26.3. My research paper is about a study on shear strength of marine soil by using waste paper sludge as an additive material. First of all, I would like to introduce what is marine soil. Marine soil is a soil with low shear strength and high compressibility. According to Ali and Al-Samari 2013, marine soil can be described as a soft sensitive soil that is always associated with high settlement and high instability, poor soil properties which are not suitable for engineering requirement, uncertainty of performance, low unconfined compressive strength of between 25 to 50 kilopascal, and flat or featureless surface. Meanwhile, waste paper sludge is a waste generated from pulp and paper industry which already known as a main source of pollution and generally have no economical value. According to Teja et al. 2016, waste paper sludge contain kaolinite which on heating at high temperature become metacholine, which help to reduce swell and as much as possible and increase the soil properties. There are three objectives of this study. First, to investigate the physical properties of plain marine soil and marine soil with different percentage of waste paper sludge. Second, to determine the engineering properties of marine soil such as shear strength by using waste paper sludge as soil stabilizer at different percentage. Third, to analyze the optimum percentage of waste paper sludge that give the maximum strength. Now let's look at methodology and scope of study. The soil sample was taken from Kampung Sungai Buaya, Banteng, Selangor. This area was identified having marine soil by Geological Map of Malaysia. This study is to identify the physical properties of soil which include moisture content, particle size distribution and attribute limits. The engineering properties of soil such as optimum moisture content, maximum dry density and shear strength also been determined. All the parameters was tested on plain marine soil and marine soil with three different percentage of waste paper sludge which are 2%, 5% and 8%. The waste paper sludge was taken from Paskop Paper Industry Berhad at Bentong, Pahang. After having several testing on soil sample and waste paper sludge, let's go through the result and discussion. First, particle size distribution. Wet sieving had been chosen to determine the percentage of grain size contained within a soil since the soil sample is in the form of sludge. We can classify that the soil sample as sandy silt, which contain 25% of sand, 53% of fine or silt, 22% clay. Second, moisture content. The moisture content of the soil sample was determined accordingly to the soil condition it was taken. It was 10:30 AM with the wet surface of soil due to the raining event a night before. Natural moisture content for the Banteng marine soil are 74.72%. Based on range of degree of saturation versus soil condition, the soil condition at this site can be classified as wet. Third, specific gravity. Specific gravity of soil sample is 2.479. According to Ramamurtya 2007, specific gravity of marine soil at Central West Coast Peninsula Malaysia is in the range of 2.45 to 2.65 and clung is in the range of 2.53 and 2.6. So this result satisfied the Ramamutia statement. Now let's look at a table limit test result. Result shows that the value of plastic limit is increasing with the increase of WPS percentage. Meanwhile, the value of liquid limit and plasticity index are decreasing with the increase of WPS percentage. The result has a significant value with research that have been done by Teja et al. 2016, whereas liquid limit and plasticity index of swelling soil has been reduced to 34.3% when treated with waste paper sludge compared with untreated soil. Now let's go through the data for engineering properties. First, compaction test. From the result, it shows that when the percentage of waste paper sludge increase, the maximum dry density decrease whilst the optimum moisture content increase. With the addition of 2% waste paper sludge resulted in higher maximum dry density when compared with other percentage. The second data for engineering properties is from triaxial test, which is consolidated Nricon test. The table shows the summary of derivative stress varies with waste paper sludge. The derivative stress of marine clay stabilized with WPS was improved from 290 to 636.3 kPa at effective stress of 200 kPa with the addition of waste paper sludge of 0% until 5%. Then, with the addition of 8% of waste paper sludge, the trend of graph indicate the decrement in derivative stress from 636.3 to 387.3 kPa respectively. The graph also presents the trend and pattern of the derivative stress of marine clay with different percentage of waste paper sludge as stabilizer at different effective stress. The table shows the summary of effective friction angle and cohesion varies with waste paper sludge ratio. The graph presents the correlation between friction angle and cohesion. The result shows that the effective friction angle of marine clay stabilized with waste paper sludge was increased from 13 degree to 26.5 degree continuously with the addition of waste paper sludge from 0% to 5%. But then, after the addition of 8% of waste paper sludge, the trend of graph indicate the decrement in friction angle from 26.5 degree to 22.5 respectively. The marine clay with the addition of 5% waste paper sludge shows the highest total shear strength since it has the highest increment value of Nricon cohesion from 70 to 99 kPa. It is due to the cohesion between particles, which is interparticle friction of waste paper sludge and marine soil and electrostatic attraction between ions. As for the conclusion, the value of plastic limit is increasing with the increase of waste paper sludge percentage. Meanwhile, the value of liquid limit and plasticity index are decreasing with the increase of waste paper sludge percentage. Soil sample with 0%, 2% and 5% of waste paper sludge can be classified as silt with high plasticity, and the classification of soil sample with 8% of waste paper sludge is silt with intermediate plasticity. With the addition of waste paper sludge to the soil samples resulted an increasing of optimum moisture content and decreasing the maximum dry density of soil. 2% addition of waste paper sludge to soil give the highest maximum dry density, 1.65 gram per centimeter cube compared to other percentage, and definitely become the best condition of soil with lowest value of optimum moisture content. The 5% of waste paper sludge is the optimum percentage to stabilize the marine soil as it improves the total shear strength with the increment 103.85% of friction angle from 13 degree to 26.5 degree compared to marine soil only. The cohesion value also increased 41.43% from 70 kilopascal to 99 kilopascal. Recommendation for this research. This research only considered three ratios of specimens which are 2%, 5% and 8%. In order to obtain the better, precise and consistent result, more ratios should be tested to ensure the accurate optimum value of waste paper sludge in order to achieve maximum shear strength of marine soil. The limitation of this research is only to determine the maximum shear strength of the marine soil by using waste paper sludge as a stabilizing agent. In order to achieve that, the researcher only focused to the triaxial test to determine the stress strain behavior. To understand more about the relationship between the shear strength and the engineering properties of marine clay, more testing should be done, especially on physical, mechanical and geological properties of soil. That's all from me. Thank you.